and I'm going to present the preliminary results of a global systematic review that we are conducting. In general, as we probably all know, the consumption of raw and lightly preserved fish species has increased worldwide, and it has attracted a lot of interest and a lot of people trying to exploring new tastes. Just a second, there is a lot of noise here. Just a second. Okay, sorry. As I was saying, if preventive measures are not correctly put in place, these new habits favor the transmission of parasitic fish-borne zoonosis. So among them, Eustrongylides may affect several freshwater fish species, acting as second intermediate or partenic hosts. And as you can see here, the cycle is indirect. So we have definitive birds as, wild birds as definitive hosts, oligochaetes as first intermediate hosts, and several species of fishes as second intermediate or paratenic hosts. So again, you can see here how the cycle is quite complex and involves several species of different vertebrates and invertebrates. Currently, 3 species are accepted: Eustrongylides ignotus, excisus, and tubifex. As I was mentioning, Eustrongylides is also responsible for rare zoonotic infections. Currently, at least 5 human cases have been described in the US and 2 in South Sudan. As you can see here in the table, you can find some details if you're interested in the clinical cases, in the clinical aspects of the cases. They all involve surgery of abdominal surgery to resolve the problem, because all the infections were due to the ingestion of raw or even live fish, and the live parasites penetrated into the gut of the people. So the worms had to be removed surgically. The cases reported so far, as you can see, were described in the US and in South Sudan. No human infection has been reported in Europe or in Asia so far, but in Italy, as well as in other countries, there is an increasing presence of these parasite in fishes, and in particular in Italy, which is the places we are working. Recently, it has been described both in central Italy, also close to Pisa, where we work, and in the north of Italy, in some alpine lakes. So, given all this interest in the parasite, we decided to investigate its global epidemiology in freshwater fish species at the global level. So we decided to conduct a bibliographic search on Google Scholar, PubMed, and Web of Science. We used as search string 2 words, Eustrongylides and fish, so a very broad search string, using 2015 and 2020 as time frame. Although, to be more complete, I have to specify that we are now investigating also the 5 years before, so 2010 to 2015, in order to have a 10-year period. We investigated papers in English, Italian, French, Spanish, and Portuguese. And we decided to use the following data as inclusion criteria. So the papers were included if they presented this data: investigated fish species or genus, sampling site at least country, number of examined species, and number of positive specimens or prevalence. In addition, we recorded these other data. So we wanted to know what kind of method for parasite detection the authors used, what kind of identification was applied, so morphological or molecular, the mean intensity, and the larval location, which can be visceral or muscular, and of course it's very important for the transmission. So giving you the first results of these 5 years, first we found 686 scientific papers. When you do a systematic review, you always find a lot of papers. Then you have to do deduplication, so to eliminate the doubles, the same articles retrieved from different databases. And then you have to assess the inclusion criteria, the ones that we just saw. So we only kept 61 scientific papers, approximately 10%. In these scientific papers, 101 fish species were investigated, and 6 general, together with 6 genera. Of these, 76 different species and 1 genus were positive for the larvae of Eustrongylides. So a very wide range of species. But if we think of the cycle that we saw at the beginning, this is not surprising, because this species, as Anisakis, can have a very wide range of fish hosts. The prevalence rate varied widely from 0.13 to 100% of prevalence. The parasite was mainly in the viscera. You can see here in the pictures what they look like, here in particular in the muscle. The presence in the muscle is not so rare. In fact, it was reported to be present in the muscle in around 30% of the scientific papers. As far as the identification method is concerned, most of the articles only applied morphological identification. I will show you in a second what they look like at the microscope and give you some tips on the morphological identification. So molecular identification was only used in a few articles, in particular only in 4 articles. Here you can see again this another picture of this big scale sun smells, which are basically as big as the worms. The worms are often called the big red worm because they are 3 to 5 centimeters long, and they are bright red. So of course they are quite visible. And this is the macroscopic aspect. You can see there are 2 rings of papillae in the cephalic area. And this is the caudal area of the male and female, because they are larvae, but they are 4th stadium larvae. So you start to see the genital primordium, and you can differentiate male and female. As far as the countries where this parasite was studied, you can see that Brazil is the darkest country. So most of the studies that we found in the systematic review were conducted in Brazil, followed by USA and Iran, Italy and Turkey, as well as Nigeria and Ethiopia. And also the east of Europe was widely investigated in different epidemiological studies are being conducted in different countries. We focused on the 10 most investigated species, which are the ones that you see: the big scale smell, common carp, tilapia, and roach as regards the predator species, while pike, trahira, which is a species from Brazil, the black bass, perch, pike perch, and catfish for the predator species. I made this, we made this distinction because it's quite important to consider if the species is a predator or not, because the prevalence rate can vary widely. Of course, the predator species generally have higher prevalence rate because the larvae can accumulate throughout their life due to the fact that they eat not just that they eat the non-predator species which have acquired the infection from the first intermediate hosts. So what can we say about the results of this systematic review? First of all, that the genus has a global distribution and a wide host range. So this is confirmed. Beside species, pentophagus fishes like big scale sand smelt, which was the small fish that I showed you in a couple of pictures, Eustrongylides was reported in several predatory species such as perch, pike, especially in Ukraine, but also in Turkey and in Serbia. Beside these species, which were the most commonly investigated, also other species of great commercial appeal were examined, such as the Persian sturgeon in the Caspian Sea, the brown trout in Norway, tilapia, and also other species of African catfish in the African continent. Of course, the presence of Eustrongylides is important from 2 points of view: the public health point of view, and also, as we will see in the next slide, for its impact on the quality of the seafood product. As far as the public health point of view, we can say that there is a growing attention towards Eustrongylides nematodes as zoonotic agents. I showed you that the number of cases is quite scarce, but I also showed you that this parasite is widely distributed globally and in a very wide number of species. So, and also it is commonly present in the flesh, in the muscle, in the part that is consumed. When we speak about the zoonotic potential, we also have to think that to note that the human cases were not molecularly characterized. So we are not sure of which of the 3 species of currently recognized in the genus is actually involved in human cases. And therefore, the zoonotic potential of the 3 species, as well as their geographical distribution, needs to be better characterized. I already mentioned that this parasite may also have an impact on the quality of the seafood, on the commercial aspect. In fact, they are clearly visible. We saw that they are red and 3 to 5 centimeters red, and generally quite active after the death of the fish. So their presence, especially if in a massive infection, can have a negative impact on the marketability of the fish. Clearly, fish processing, such as visceration, trimming, and preparation, in particular the type of cooking, can greatly influence the risk of transmission to humans. And the risk of transmission is, of course, higher if preventive measures are not put in place to ensure the safety of freshwater fish products. So, getting to the conclusion of what we found so far, based on this systematic review, and also based on some experimental data that we have from the north of Tuscany, that some colleagues are also collecting from other lakes in Pisa, but around Italy, as I showed. There are some rising prevalence rates observed in some areas, and these have been observed also in the Danube and in the Caspian Sea, and they have been attributed to climate and anthropogenic changes, which may impact especially on the first intermediate host, but as well as on the definitive hosts. Currently, there is a poor molecular characterization of the genus, as I said. So there is the need for further surveys to better understand concerns risks and impact on seafood quality. And therefore, we have been lucky enough to have a dedicated project financed by the Italian Ministry of Health. So that's why we decided also to present this topic to this international seminar. And also, we wanted to present this topic because, of course, issues in molecular taxonomy need collaboration among researchers in order to be able to collect and genetically characterize specimens from different countries. So if you are interested in this topic, if you have access to freshwater fish species, please contact us. Thank you very much.